Hello, welcome to your second triple only lesson. So if you are a trilogy student, you do not have to do this lesson. This is extra content for triple students only. Okay, today we're going to be having a look at carboxylic acids. Okay, so today you're expected to know that carboxylic acids have the functional group COOH. You need to know names of the first 4 carboxylic acids, the structures and the formulas of them, how we write those. You're also expected to know how the first 4 carboxylic acids react with carbonates, how they dissolve in water, and how they react with alcohols. Higher tier only are expected to explain why they are weak acids in terms of ionization and pH. And you are also expected to know about esters, which is when carboxylic acids react with alcohols, but you don't need to name any of them other than ethyl ethanoate. Okay? So to start with, we'll say what all carboxylic acids contain. Okay, so they all end in COOH, which is a carbon atom with a double bond O and a OH group. Okay, thinking back to the alcohols group, so this is our alcohol functional group, and when we add in a double bond O, we get a carboxylic acid. Okay. So because they are an acid, they will react the same way as acids do with metals and carbonates and oxides. You'll see bubbles when they react. So if it's a carboxylic acid reacting with a pure metal, you would end up with hydrogen being produced. When a carboxylic acid reacts with a carbonate, you would see carbon dioxide being produced. But as an acid, they are a weak acid. Okay. Now, if you can't remember this, you'll need to do a little bit of revision of the chemical changes unit, where you learn about acids and alkalis, concentration and dilution, and strong and weak acids. So they are weak acids, which means they don't always give up their H plus ion, which makes them an acid when they dissolve in water. So normally a strong acid, such as hydrochloric acid or sulfuric acid, they fully dissociate, which means they give away their H plus ions. Every single molecule of them in that solution will give away that H plus, and that will go and attack the metal or the carbonate or whatever it's reacting with. Okay. Weak acids don't do that. Okay, they only ever give away up to about half of their H plus ions. Okay, which means they don't react as quickly or as vigorously as strong acids do. So they normally take a little while longer because in the solution there is less H plus in that area, which means they're less concentrated. Okay, so you end up with H pluses in your solution, but not as many as when you have a strong acid. Okay, so that's higher tier only. So if you had the same concentration of a hydrochloric acid and let's say ethanoic acid, so carboxylic acid, they would have different pHs because the pH is showing the concentration of the H plus ions. Okay, so in our strong acid, they'd have a lower pH, so 1 closer to 1 or 0, and our carboxylic acid would still be acidic, so it would still need to be less than 7, but it would be closer to the 7 than the 1, so more like a 4 or a 5. Okay. Now with naming of alkanes, alkenes, alcohols and now carboxylic acids, they all depend on how many carbons there are in your chain length. Okay, so hopefully you can remember the prefixes. If you can't, pause the video, try and remember your mnemonic. Okay, so monsters eat pupils but prefer hamburgers. Okay, our prefixes should be meth, eth, prop, bute, pent, and hex. Okay, now with the alcohols and the carboxylic acids, you're only meant to remember the first four, so meth, eth, prop, and bute. But I will include pent and hex just so you can see how the pattern continues, and it will continue no matter how many carbon chain lengths you've got. Okay, so we're going to name our carboxylic acids. Okay, so the first one we have methanoic acid. So onto our prefix we put the suffix anoic acid. Okay, pause the video and see if you can name the next 5 carboxylic acids. Okay, so let's go through the answers. We have ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, and then hexanoic acid. Make sure you're ticking your answers as you go through. So give yourself marks, okay? All of these could be marks in an exam. So our structures, when we draw out the structures, we always have C double bond O and COH on the end. Okay, you can draw it on the left hand side or on the right hand side. All of the images I found on Google were all on the right hand side, so I've just stuck with that. Okay, it also helps when writing out our formulas for our carboxylic acids. They all need to end in COOH. That shows you that it is a carboxylic acid. Okay, so our methanoic acid is HCOOH. Ethanoic acid is CH3COOH. See if you can write out the formula for the remaining 4 carboxylic acids. Okay, so propanoic acid, we have CH3CH2COOH. Butanoic acid, following on from that, pentanoic acid, and hexanoic acid. I do apologise that the text has got smaller and smaller each one, but I wanted to show them in a line. When you are writing them out in an exam, there should be enough space to write them because they probably won't ask you for something really long. However, if you go on to the next line, it doesn't matter. Just put a hyphen in the middle of it like you would normally with a word that you've got too long and started on your line. You'd put a little hyphen in the middle of half of the word and then continue writing on the next line. Okay? So you're expected to know how they react, and we've already said that carboxylic acids will react just like the other acids. However, because they are weak, they'll be slower. So these are all reactions that you will have seen in the chemical changes unit. So you'll have seen a metal plus an acid giving a salt and hydrogen. Maybe you remember your MASH equations, the M for metal, the A for the acid, the salt, and then the H for the hydrogen. Hopefully you remember from making some crystals of your metal oxides and producing an insoluble salt. So you have your metal oxide plus your acid gives a salt and water. Your metal carbonate plus an acid will give a salt, water, and carbon dioxide. So you'd see bubbles with that example. Okay. with these, looking for exam questions that have previously come up, I couldn't really find much with carboxylic acids. They didn't really have that many exam questions. It is in the spec, which means you're expected to know it, but it's not been tested on before, if that makes sense. So the likelihood of it coming up this year or next year is quite likely. Okay, they don't have enough space to test the whole spec every single year, but they do need to do it every 4 years. Okay. We know that carboxylic acids and acids in general dissolve in water, but because carboxylic acids have a big carbon chain length attached to them and they're not a small molecule like hydrochloric acid, they might struggle with that. So the smaller ones, between 1 and 4 carbons, which you're expected to know about, dissolve in water. However, the solubility decreases as the carbon chain length increases. Okay, so the longer the chain length, the less soluble. So it's the same pattern as with alcohols. The longer the chain length, the less soluble. Okay. When they dissolve in water, they produce these interactions between hydrogens and slightly negative oxygens. So this can happen with 2 lots of ethanoic acid. You could also have interactions between water, the H2O molecules, and them as well. That is not something you're expected to know about the hydrogen bonds. However, it does explain why longer chains don't really bond with the hydrogen and oxygen in water very well with the longer chain lengths. Okay, that's why they can't dissolve as well. Now the next bit is possibly, I would say, the hardest part of the whole unit. Okay, the hardest part about hydrocarbons and organic chemistry in general. Okay, so alcohols, which you learnt about last lesson, and carboxylic acids, which you've learnt about this lesson, can react together to form esters. Now, esters are really useful chemicals, so useful. Okay, they often smell really smelly. The vast majority of them smell lovely. So we've got some that smell like raspberries, some that smell like pears. They smell very nice, some smell floral. So they're often used in the food industry and in perfumes and things like that. There's some esters that don't smell very nice. There are some esters that smell a little bit like fish oil. We've got some esters that smell very chemically, like nail varnish remover. So they are normally used as solvents. So they dissolve other important chemicals. Okay. Now, alcohols and carboxylic acids react in a condensation reaction. Now, that means a reaction where 2 molecules combine to form a larger molecule, producing a small molecule, such as H2O, as a byproduct, which is why it's called a condensation reaction. Not every condensation reaction produces water as a byproduct. Some produce hydrochloric acid, HCl, others produce other things, okay, but it's normally water. So you can see our carboxylic acid on the left-hand side here. This R means it can be any chain length. So it could just be a H. It could be a CH3. It could be a CH3CH2. It could be 100 carbons long. Okay. The same with this R group. This can be 1 carbon long, or it could be 150. Okay. You see in blue here, the OH from your carboxylic acid and your H from the alcohol join together to form H2O, and the O from the alcohol joins on to your C from your carboxylic acid, okay? So you end up with an ester functional group. So we have a C double bond O, CO, and then the O joins on to your other carbon chain lengths, okay? So an example here, we have propanol, an alcohol, and we have ethanoic acid. Our H2O molecule is joined out the middle, and we have our CO bond, okay? Now you don't have to know the name of this ester, but it shows where the name comes from. So the propyl bit at the start comes from our alcohol. Our alcohol has got 3 carbons in it, so it's prop. Okay, that's where our propyl comes from. The second part of the name comes from our carboxylic acid. So in this case, it's ethanoic acid. To make it an ester, we change the oic part of the oic acid to O8. So it's ethanoate. Okay, so this ester is called propyl ethanoate. You're only expected to know ethyl ethanoate. That's the only ester that you need to be able to name. You don't have to name any of the other ones. Okay, so we have ethanoic acid here and we have ethanol here, so both with 2 carbons in the chain length. Okay, our OH from our ethanoic acid and our H from our alcohol are going to join together to produce water, and we're going to be left with ethyl ethanoate. So we have our ethyl from our alcohol part, and we have our ethanoate from our ethanoic acid part. Okay, you need to be able to draw those structures, and this functional group is in the middle here. Okay, you need esters in day-to-day life for lots of things. Okay, so we use esters as solvents. That means they dissolve other things, so such as the pigment in paint. Solvents are used to dissolve the pigments in nail varnish, so it will dissolve your nail varnish off your nails. Okay, it's also used in the food industry in flavourings. So on screen here you can see a sweet, they're called pear drops. They contain a artificially made ester that tastes and smells like pear drops. You can have other esters that smell like lemon, like orange, like raspberries, and you can make all of those in a lab. Doesn't mean they're dangerous, but it does mean they're artificially made. Some of them smell really nice, so they're used in perfumes a lot of the time. Esters can be used as a surfactant. Now you may not have come across the word surfactant before. A surfactant means that we have one end that is hydrophobic and one end that is hydrophilic. So one end that loves water and one end that hates water. Okay, that means that it can take away lumps of grease and oil that comes from food. So our fairy liquid here in the middle, our dishwasher, is a surfactant. So that means it can take away fats and oils. Your body washes and your soaps that you clean your hands and your body with also do the same thing. So they take away the dirt and the grease and the oil from your skin. So soap and shower gel and shampoo and things like that, they also contain esters. Now, something you will learn a little bit more about in other lessons. Okay, so for everyone there is the polymer lesson, and then for you guys there's an extra 2 lessons on how polymers are made, polymerization. And one of the ways is condensation polymerization, which, as you guessed it, is how esters are formed. Okay, So polyesters, you also may have heard of polymers being called plastics. But polyesters are what a lot of your clothing will be made from. Okay, so we've got lots of cloth down here. They're polyesters. And also what makes you, your DNA. That is a polymer. Now the pairs in the middle, your amino acids, your adenine, thymine, guanine and cysteine, those 4 amino acids will join together with an ester bond. Okay, now the structure of the amino acids you do have to know, which we will go over in one of your extra polymer lessons. Okay, that's it from me today. Thank you for listening.